Thank you, Ryan. Hello, everybody, and welcome back to the second installment of Obesity in South Africa. Thank you for coming back today. You're in for a real treat. It is my absolute honor today to introduce you to my dear friend, David John Hume, Dr. David John Hume. And I'm going to give you a little brief introduction to him. So, born in Uitenhage in the Eastern Cape in 1988, David spent many of his formative years growing up on the family farm in the Klein Karoo. After matriculating from Union High School in Graaff-Reinet in 2006, he went to Stellenbosch University to do his undergrad, graduating cum laude, majoring in sports science, psychology, and English literature. He then made the best decision of his life to come to UCT, where he did his honors and his doctorate at the Department of Exercise Science and Sports Medicine. There he graduated with a PhD in sports science, and the title is Mind the Gap, Brain Behavior Barriers to Successful Weight Loss Maintenance. He graduated in 2015, where he was also appointed assistant lecturer in the department. Since then, he's been an ad hoc postdoctoral research fellow at UCT's Department of Psychiatry, and he is now a third-year MBCHB student in the Faculty of Health Science. David has been granted numerous international awards and research grants, including in 2015 being honorarily invited to join the Bright Young Minds, which is a very prestigious fellowship organization which selects 100 of South Africa's emerging leaders under the age of 32 to foster. So everyone, please welcome my dear friend, Dr. David John Hume.
Wow, I am already blushing, and that was quite unexpected. I didn't know Brian was keeping tabs on my life to that degree. So before I begin, I would just like to extend my most heartfelt thanks to Brian for covering our first lecture. I've always had immense trouble contextualizing and conceptualizing the humanities and the social sciences, and whenever Brian speaks about it, it always seems so easy, but when I try and read up on it, I do get a bit carried away and confused by the whole topic. But before we begin, it's Ryan, right? He's our mic guy. He has to leave at 8:30, so if we do run over time, which we very much are likely to do, I'm going to switch the mic off, he's going to pack it away, and we'll continue the discussion without the microphone. I'll start screaming at that point, and then hopefully I'll be able to project my voice. But today we're going to step outside of the social sciences, away from politics, away from philosophy, and away from the humanities, and get our hands dirty with something that I find a bit more comfortable, and that's biology and physiology and how our brains really are implicated in obesity. So as Brian mentioned, I had a year or two where I stepped away from doing studies. After my PhD, I was a bit fed up, so I took a year or two just to kind of, do some work, and now I'm back at university studying medicine and surgery. So it's very nice to be in front of the class for a change again, as opposed to sitting in a class of 260 third-year medical students. So it's nice to be in control again. But today, I want to just revisit the statistic, which I think that Brian did mention briefly yesterday, and that was the frightening fact that in 2014, the World Health Organization empirically supported the fact that 39% of our adults aged 18 years and older, and 39% are overweight, and 13% are obese globally. And that means that most of the population that lives on our beautiful planet live in countries or on continents where more people die from overnutrition and obesity than they do of underweight, wasting, and malnutrition. But then where does South Africa fit into this context on a biological level? We did speak about South Africa's problematic political history yesterday, but where do we fit in with statistics? So about 25.3% of our male population, these are our adult males, are overweight, and 13.5% are obese. And as you can see here, a staggering 27.3% of our females are overweight and 42% are obese. So I'm picking up a lot of interference with the mic, but hopefully that'll resolve itself. Is it really bad, or am I just hearing things?
So when you move it by hand.
I'm trying not to move too much. Okay. Just fix that before I continue, because there's nothing worse than a whole lecture where you can't hear somebody. Is that better? Can you guys hear me? Back? Good. Okay, so a staggering 42% of our female population in South Africa are obese. And people always ask me, why do you study females? You'll see whenever you read any of my research or look at any of my data, it's always on female populations. And that's firstly because obesity does burden our female population to a much greater degree. And secondly, because when you look at one sex, you really do control for intersex differences. So, and females biologically are a little bit more complex than males because females' endocrine systems are a little bit more convoluted and complicated. So it's a bit easier to control downwards, to take away variables than to add extra variables, if that makes sense. Okay, so I thought, when I put together this talk, what way better to understand obesity and overweight than to look at the journeys and the differences between the successful dieter and the unsuccessful dieter. That's a really nice juxtaposition to kind of kick off with, and just to kind of explore the differences between people that actually do end up reaching their goal weight and maintaining a healthy body weight versus people that always struggle with unhealthy levels of adiposity throughout their lifespans. So sadly, only about 20% of us who start diets reach our goal weight and manage to keep that weight off. And for interest sake, this was part of my PhD, it was part of my literature review. And for interest sake, the top 8 behavioral or physiological attributes of the people that successfully maintain weight are these 8 here. They look a bit blasé and a bit bland now, but these are all from empirically controlled for studies, from really good studies which have been published in The Lancet and several other journals which really have great impact factors and are very reputable. But the first thing here is that successful weight loss maintainers tend to consume a low-energy, low-fat diet. Don't let the low fat confuse you, though, that we are referring here to trans fats and hydrogenated fats. So these are unhealthy fats, not healthy fats. Then the daily consumption of breakfast. So your grandmother and your mother were onto something when they said breakfast is the most important meal of the day. Obviously, and not surprisingly, these populations tend to engage in at least moderate to high levels of physical activity every single day of the week. They also show monitoring behaviors, such as frequently weighing themselves or measuring themselves. Also, elevations in eating restraint. When I say eating restraint, I'm referring to how much of my cognitive capacity, how much of my mental capacity I can use to control my eating behavior. How much of what I think and what I can control, top down, can I stop and inhibit? So these people are really good at inhibiting behaviors. Also, they recover very quickly from small weight relapses. If they pick up 2 kilograms or 3 kilograms, they lose it within a few weeks. It doesn't stick around for very long. They also limit screen time, once again not surprising in our day and age, limited TV, limited PC usage. And also, this was surprising to find in a study, but a really good and effective weight management during the holiday periods. And coming through Christmas and New Year's, I think we can all understand why that is high on the list. I mean, this happens once every 12 months, and that definitely accumulates after years and years of over-consuming over the holiday periods. So these data, for interest sake, were sourced from the National Weight Control Registry. And the National Weight Control Registry is the only registry in the world that has over 5,000 people in it that have managed to keep their weight off after being overweight or obese. And this data set is based in the US. And it was founded by someone called Rena Wing, who is based at Brown Medical School. And I was lucky enough to meet her a few years ago when I went to my first US conference. So a really good way to explore what successful people do to keep weight off. And this database is continuously updated and continuously trawled for data, and immensely good studies emerge from this data set every single year. So what about the rest of us? The 80% of us that are never able to reach that goal weight and keep it off. Surprisingly, most of us do reach our goal weights, but it's the relapse that kicks in really shortly. So within 3 to 6 months, you'll find that most people that have lost weight have regained it all. But what is it that pushes us back to square one? Why do we relapse? And that was really my fascination, and that's what really made me passionate about doing my PhD. What causes weight relapse? And for interest sake, the reason why I went into obesity research was because I was obese as a child and as an adolescent, and I really struggled with it. So it really was something that hit home and something I wanted to research. And people always say, like, you're so skinny, and how dare you speak about obesity because you don't know anything about it. But even to this day, I find myself monitoring my weight, monitoring what I eat. It's a constant thing which I look out for all the time because I know that I'm inclined to bounce back. That's my wild type. In genetics, you call it your wild type. Your wild type is what you're innately meant to have. My wild type is I'm meant to be obese. So, sad statistic. So, just to make a point, I want to show you how sensitive your bodies are. If you eat 300 calories over and above what you eat every single day for the next 23 days, you will gain 1 kilogram. 300 calories looks like 15 macadamia nuts, 3 lint balls, or 1 medium-sized muffin. That's not a lot. I'm sure all of you can easily consume that over and above what you eat every single day. So, and this is where we bring in the idea of energy balance. And I'm sure most of you understand this concept very well and have been introduced to it several times. But if you burn the same number of calories on the right of the screen, if you burn the same number of calories that you eat, you should be weight stable, right? You should remain in the same weight band relatively throughout your life. If you're in a positive energy balance, so if you burn fewer calories than you consume, then you should gain weight, and the other way around. If you are in a negative energy balance, if you're burning more calories, eating fewer, you should lose weight. It's that simple. But later on, I'll show you that it's not that simple, and it's not always your energy balance that counts the most. It might be other variables. But that's just to illustrate how sensitive our bodies are, and how easily it is for our physiology to use small daily changes to make big accumulated changes over the long term. And 23 days is not long term. That's less than a month. So I want to go back to this. Another very lay kind of idea, a very lay topic, survival mode. How many of you have heard of your friends saying, don't eat too little because your body will go into starvation mode or survival mode? I'm sure most of you have heard that, right? That's very true. It does happen. But it's a bit more complicated than what people portray it to be. And that's also something that I really love to research. So let me show you this diagram. And I've really tried to make this as simple as possible because I really want you all to walk away with just understanding how these different domains work. So when I, at the top, start to lose weight, my body makes several changes throughout. And those changes relate to my physiology, to how I behave, and how my brain perceives exercise and food. And all of those changes, whether they be in my physiology, my behavior, or in my perception, they all have one end goal, and that's to upregulate my energy intake and to downregulate my energy expenditure, to push me into positive energy balance so that I can gain weight. Does that make sense? Right. So, it sounds a bit blasé and a bit broad, but it really does happen. So let me talk about these things one at a time. Let's look at physiology first. That's the first and the biggest domain, and the one that I'm sure if you are a biologist you'd want to research. So there are at least 8 of them, and these have all been very widely researched, and they are spoken about at almost every single obesity conference you go to. So the first one, your resting metabolic rate, your BMR, your basal metabolic rate, it does drop. After you willfully start to lose weight, and you consciously decide, I'm going to lose weight now, and you start down-regulating your energy intake, your basal metabolic rate does drop. So does your TEF, your thermic effective feeding. Your thermic effective feeding is how many calories your body uses to digest your food and to store your food. That whole system becomes more efficient. So you use fewer calories to support basic things like food digestion and energy storage. The second thing on the list is an increase in skeletal muscle work efficiency. Same principle. I can do more exercise, I can work harder, and I can generate more forces with the same unit of energy, the same number of calories. The next thing, this relates to our gastrointestinal tracts, our digestive systems once again. Our bodies become better at actually extracting energy from our GITs. From various parts, it's mostly your small intestine, from your jejunum and your ileum, the second and third parts of your small intestine. That becomes a lot more efficient at extracting energy. The fourth thing is atypical SNS function. So this is your sympathetic nervous system. So when I talk about sympathetic nervous system, I want you to think of the heart. And we research heart rate, we call it heart rate variability in our research populations. If you think about your heart, it should be a very responsive organ. It should respond aptly to whatever is in front of you. If you see a stimulus or a cue, it should be able to speed up or slow down depending on what your body needs to do, right? It should be a very adaptable and a very pliable organ. However, in people with obesity, people with cardiac disease, people that experience premature death, they all have decreased heart rate variability. And when I mean heart rate variability, if you think of a beat and a beat and a beat, variability means there's more pliability and flexibility between those beats. With obese people, or people with obesity and people with chronic disease, those beats are equally spaced out and they don't really change. So their hearts become a bit less flexible at responding to the environment. And the next one here, which we all know is a precursor to diabetes, is a decrease in insulin sensitivity. So your cells all over your body become less sensitive to hormones that should unlock the cell membranes for sugar to be absorbed, for glucose to be absorbed, and vice versa. Also, we have an upregulation in appetite and a decrease in satiety, so we feel less full and more hungry most of the time. And we also have changes in substrate oxidation. Over here, I'm talking about metabolic flexibility. Same thing, look at the heart again. Now think about your metabolic pathways. If I give you a high-fat meal, you should be able to switch into fat-burning mode or fat oxidation mode. If I give you a high-carbohydrate meal, you should be able to switch on those pathways to oxidize that energy substrate. People that have obesity and people that die prematurely also cannot switch between those pathways. They stick to one pathway most of the time. So when they eat something that they can't digest, that food or that substrate either floats around in their blood or gets stored for later energy usage. Okay, so flexibility is a really good keyword to remember. And then also a decrease in resting and exercising fat oxidation. When I did my honors research study, I put 50 women on a cycle ergometer. I made them cycle until they couldn't cycle anymore. And I found that most of them couldn't burn fat adequately at the lower intensities of exercise. So there's also an inability to burn certain kinds of substrates during exercise, especially moderate and mild exercise, surprisingly. Okay, so that's physiology broadly. And now let's look at behavior. These are a bit easier to understand, so I don't have to spend so much time explaining them. So the first thing, obviously, when we become deprived of calories and we start trying to lose weight, our bodies generally want to increase the frequency at which we eat. We eat more meals during the day, and those meals also become bigger, and the portion sizes automatically start increasing. Also, we automatically and innately start craving and preferring energy-dense foods. If you have an array and a buffet of food in front of you, the person that's losing weight or going into weight loss mode will likely want to naturally go for the energy-dense food. Our brains have this clever way of figuring out which foods have the most energy in them. Then an increase in dietary disinhibition. When I spoke earlier about cognitive control and executive functioning, I was talking about how much of our brain we can use to override bad behaviors or unwanted behaviors, behaviors that don't support long-term weight loss maintenance. That becomes a little bit more convoluted. Also, an increase in emotional eating. So Brian mentioned this yesterday with Bridget Jones. It's a little bit more physiological as well. And then also a decrease in volitional or planned physical activity, as well as a decrease in non-exercise associated thermogenesis. So you automatically, it's fascinating what kind of research is out there, but there are studies on fidgeting, for example. People that are skinnier fidget more. They move around more all the time. So that even starts to decline after you start going on a low-calorie diet, for example. Okay, so let's look at perception. So this is something I'll come back to later in the talk. But when we start losing weight, we tend to underreport the amount of calories that we eat daily. So if I ask somebody that's going on a diet or somebody that's obese or has obesity, how many calories do you consume per day? They will tell me they eat this number of calories per day. But in actual fact, they're eating that much. So there's a gap there. There's a discrepancy between what they're reporting and what they're actually doing. But it's not intentional. It's not because they want to lie to you. It's just because their brains perceive that to be the truth. And the same thing with physical activity, but the other way around. So they perceive to be doing more, maybe because the perceived intensity and the perceived duration of the exercise is longer and more difficult. And then also, there's an increase in the sensitivity of the brain, the actual neural circuits and the different parts of the brain. And if anybody went, there was a talk last year, I think, on addiction. I think Dr. Samantha Brooks presented it, and I don't know if any of you went to it. So she spoke about anorexia and how the neural circuits in the brain are implicated in anorexia. We have done similar research, but using different modalities about neural circuits that get implicated in obesity. And I'll talk about that later. Now, the next question is, when do these things happen? Those changes in physiology and behavior and how our brains perceive food and exercise and what we do to keep weight off, when do these things start kicking in? Well, the first time they start kicking in is when you start hitting your goal weight at the bottom here. That's when they start kicking in. The second time, when they get intensified, is when you get back to square one. So in essence, what's happening here is that this is pushing you back to the beginning, and those super added changes over here are preventing you from ever losing weight again. That's why it becomes more and more difficult to lose weight again and again and again. The more you relapse, and the same with an addiction psychiatry, the more you relapse, the more difficult it is to get back to where you came from. So now let's talk about research we've done in Cape Town in this regard. So what we did, we wanted to look at these compensations, as we call them, in behavior and physiology. We wanted to see if they exist in a group of women in Cape Town. So let's talk about behavior first. We looked at 150 women, and we looked at behavior first, and we found this. So I've put the red bars are protein, the green bars are fat, and the blue bars are carbohydrate. At the top, we have the people that have lost weight and kept weight off, and at the bottom, we have people that have never lost weight and have always been the way they are. So surprisingly, we found that people that have lost weight and kept it off, they show 3% more protein intake, 5% more fat consumption, and 8% less carbohydrate and sugar consumption than people that have never had to have a journey or never had to lose weight. So that was surprising, and that was our first clue that told us that curbing sugar and carbohydrate might relate to successful weight loss maintenance over the long term. Okay, so the blue bar over here. So at the top we have people that have lost weight and kept the weight off. At the bottom we have people that have always been lean or always been skinny. We also have people that have always been obese. We also have people that have never had to have a weight loss journey. They've never intentionally tried to lose weight, or they've always been skinny. We find that the successful weight loss maintainers, the people at the top, they eat more protein, more fat, but less carbohydrate, which was counterintuitive, because if you look at any conventional dietary guidelines, you'll find carbohydrate right at the bottom of the food pyramid. 50 to 60%, and I was rolling my eyes while I was studying. I have medical school exams on Friday. I was rolling my eyes this morning because we're doing HIV at the moment, and everything they teach us is based on the conventional dietary guidelines, and to this day, carbohydrate and starch is always at the bottom of the food pyramid. But I'll come back to that later. But this was the first clue that we had, that something about sugar and carbohydrate and the way that our bodies process this, successful weight loss maintainers have figured out that this isn't good for them, and they try and stay away from this. Then we started looking at their physiology. And here, I want to come again back to this study on metabolic flexibility. We really found that the successful dieters refrain from sugar intake because, once again, they are not able to switch between the sugar and the carbohydrate metabolism and fat metabolism. If you give a successful weight loss maintainer or somebody that's obese or somebody that's struggling with weight in general a high-fat meal, or a low-carb, if you give them a low-carb meal, they will not be able to metabolize the carbohydrate as well as the general population can. So they are carbohydrate intolerant. Their bodies aren't as tolerant to carbohydrates as people that always maintain a healthy body weight. And that was looking, we fitted all of these participants with what we call a ventilated hood. We put a hood over their heads and we measure their oxygen consumption and the carbon dioxide production. And from that you can determine their metabolic rate, and you can determine which metabolic pathways are being activated just by looking at ratios of gases. And we found that those successful weight loss maintainers were carbohydrate intolerant. The last one here was perception. And this, when I mean perception, I'm talking about how the brain perceives food and exercise again. And over here I just want to highlight that, and I'm going to read it out, this conclusion of this really good study said that many adults with obesity not only underreport the amount of energy they consume, but also the kinds of food kept in their homes. So if you go and take record of all of the foods somebody that struggles from an obese person's pantry or an overweight person's pantry, they will tell you that they have fewer kind of like high-calorie foods and fewer processed foods and fewer kind of calorific foods, if you want to call it that, in their households than what they really do. Same as they will underreport the number of calories they consume per day. And this, I know these graphs are really confusing, but I'll explain them to you. So over here we have normal weight women. In the middle we have overweight women. And on your far right, you have obese women, right? The blue bars indicate what we measured with the device, how many calories they burn in exercise and movement every day, right? That's what we measured. The red bars are what they thought they were doing, right? Isn't it interesting how, as you become bigger and bigger, that gap between what you're really doing and what you report you're doing becomes bigger? So it's very well known that everybody in the general population overreports how much exercise they do. We all do it. It's a thing that has been researched for decades. We all do it. We don't do it on purpose. But the problem is that as you become more and more unhealthy and as you become more and more overweight and obese, that gap grows. Okay. And we did the same thing. I want you to focus on the two bars on the left-hand side. We took people that had lost weight, successful weight loss maintainers, and then these are people that have always been lean and have never had to lose weight. They are people that have really never had to go on any weight loss journey whatsoever. You can see that even the successful weight loss maintainers on the left-hand side, the far left, have a bigger gap than the people that have always been lean do, right? That means that is a compensation which remains after you've lost weight. That overperception of exercise, it remains and it sticks after weight loss, after you've lost weight, even in the successful weight loss maintainers, which is maybe why they compensate with their diets, because they've got to do something, they've got to tweak something elsewhere to correct something in the physical activity domain, even though they might not be aware of it, they're doing it subliminally, right? Okay. So that was another clue as to the brain's involvement in diet and exercise. There was something going on with maybe something we were eating or something we were being educated about or something we were doing was messing up how our brains perceive food and exercise and that gap between the two things. So how do we stop these things from happening, right? How do we stop these compensations from kicking in and all of these changes in our behavior, our physiology, and our perception from kicking in after we start going on a weight loss journey and pushing us back to square one? Funny enough, I was doing a study with a few US colleagues at the same time that I was doing my PhD, and we were looking at low-calorie diets. And we really, I mean, most obesity researchers really do not agree with low-calorie diets because it's not sustainable, it's not healthy. So we wanted to look at this from more of a scientific perspective. And we came up with, in addition to energy balance that we spoke about earlier, we wanted to look at energy flux. Now, I want you all to try and understand this as best you can, because if you don't, you're not going to understand the next few slides. So when I'm talking about energy flux, right, if you look at the bottom here, where the blue is, if I am a low fluxer, I eat a little and I exercise a little. But I'm in energy balance, right, because both are little, right? If I'm a mid fluxer, I eat a little bit more and I exercise a little bit more. If I'm a high fluxer, I eat a lot and I exercise a lot, right? So that's very easy to understand. But all three of those groups are in energy balance, right? Because they're all doing the same thing in exercise and in eating, right? Okay, so that's important for you to understand, because I'm going to show you some more graphs. Okay, so this is what we did with these people. We took two samples. One sample was an adolescent sample, boys and girls. I think it was about 150 adolescents. These were in US towns. These aren't South African samples. And then we also took a second sample of college-aged women. In the first, so for the first sample, we measured their energy intake and the energy expenditure, as well as their basal metabolism, their BMR, or their resting metabolic rate, and we measured their percent body fat percentage at the first year. This is 0, baseline, right? At year 1, 2, and 3 are follow-up. So 1 year later, 2 years later, 3 years later, we repeated the body fat percentage measures to see how their body fat percentage changes over time. You call this a longitudinal or a prospective study in research, and it really is one of the gold standard designs for any kind of research that you're doing. Most of the time, to save money and to save time, we look at one sample at one moment in time. So if I took all of you in the lecture hall now and I measured something on all of you, this would be a cross-sectional study. One moment in time, but lots of different pieces of data, right? But if I followed all of you over 3 years and I collected data every year and measured how your behavior changed, your body fat percentage changed, that's a longitudinal study. And that's got way more impact and way more validity if you're trying to publish your research, okay? And it's more scientifically robust. It really is a lot more convincing from a statistical perspective, and your data is good. Anyway, so this was 150 adolescents, sample 1. We measured them from 0 to 3-year follow-up, and the women in college, I think it was a group of 80 women, from 0 to 2-year follow-up. Okay, this is what we found. So yeah, the first study was 154 adolescents. The second was 75. I'm just focusing on the numbers at the top. The N's, the number of people in the population. 154 in the kids and 75 in the females. So we looked at changes in body composition over time. And this is what we found. So the red bar, the green bar, and the orange bars, the ones that are going up. This is body fat percentage over time, right? This is baseline, here 1, here 2, here 3. We measured their body fat percentage every single year. The green, the red, and the orange, the 3 going up, the people that gained body fat percentage, the people that got fatter. Those are the people that were low flux and mid flux. The only group that lost weight was the blue graph at the bottom going down. Those were the high fluxes, the people that ate a lot and the people that exercised a lot. Okay, so this proves a very important point. If you're in energy balance, all levels of energy balance are not the same. If you eat a little and you exercise a little, it might be tumultuous for your long-term weight loss maintenance. If you think about someone that does endurance training, they exercise every single day and they eat a lot. If you have any athletic friends, sometimes it's quite disgusting to see how much they can eat in one day. But those are the people that are doing it right. Those are the people that, granted, they should still be paying attention to what they're eating, but those are the people that are going to have the healthiest metabolic systems throughout their lifespans. Okay, so, but the interesting thing here is everybody's still with me. Everybody's still good. Okay, so the interesting thing that we found was, as we went up, the people that gained weight, those people showed more compensations. They showed more compensations in physiology. They showed more compensations in behavior and perception. Those are the people that experienced reductions in basal metabolic rate and resting metabolic rate. So if you're a low fluxer, if you're on a low-calorie diet and you are eating a little and you're exercising maybe moderately or little, that's why they don't work, because your systems shut down. Everything shuts down and everything starts driving energy balance up. That's why it's so momentary and it's not sustainable. So compensations increase with the people that gained weight and the people that were low flux or mid flux, and there were fewer compensations here at the bottom with the people that were high flux. They didn't show any reductions in basal metabolic rate, for example. Another interesting thing that we found was that in the low flux groups at the top, they were showing much more carbohydrate and sugar consumption on a daily basis. Whereas the people that showed fewer compensations and the people that showed higher flux, they were eating less sugar over the long term. It was the only dietary component that was different. They didn't eat as much carbohydrate. Okay. So once again, that was another clue as to how low-calorie diets and sugar consumption over the long term increase our risk for weight regain, because that's when we have compensations kicking in. Our bodies start shutting down. Those two variables were the significant differences between those groups. So now I'm going to talk about the love of my life, and that's electroencephalography. This is what I looked at for my research and my PhD, and what I'm trying to, as best I can, do on the side while I'm still in medical school. As most of the time it's quite a disaster trying to do both things, but I try. So electroencephalography, or EEG, really is a cap. It looks like a water polo cap or a swimmer's cap. You put it over somebody's head. It has lots of different electrodes or sensors, and those sensors pick up millisecond changes in brain activity over the different parts of the brain. Microvoltage, millisecond changes in brain activity over different parts of the scalp. And those voltages are sent to a computer, and you can manipulate the data and intensify the data to look at what the actual changes in brain waves are, right? So the most important thing and the best advantage that EEG has over different things like fMRI and other kinds of brain activity scanning or neuroimaging is that it is high temporal resolution. So you can look at millisecond changes in brain activity. With things like fMRI, you can only look at blood oxygenation levels, and you can't really look at you can look at second changes, but it's a bit messy, it's a bit confusing. Whereas with this, you can look at millisecond changes. So there are two different kinds of data you can extract from an electroencephalograph. The first kind of data is frequency activity or cortical arousal. This kind of data refers to the hum of your brain. Your brain, really what kind of state of wakefulness your brain is in. The second kind is attentional processing, and those are what people would call brain waves, right? You can see they look like little waves. Those really indicate how your brain attentionally processes things, the amount of attention that you're attributing to something and how much attention you're giving to it. So I want to talk about the first one, the one on your left-hand side, the first kind, the frequency activity. If you look at the blue line where it says EEG signal just above the red bracket, that's the raw EEG signal. If you're getting a brain scan done, that's the messy data, really. The computer breaks that signal down into different bands. And different bands are associated with different kinds of brain activity. For example, delta activity at the bottom here is the slowest frequency, whereas beta is the second fastest. Delta activity, if you see increased levels of delta activity in a participant or in a big population, that's normally associated with addictive-like behavior. because it activates a certain system called the dopaminergic system. Okay? And if you went to Samantha's talk, I'm sure you remember that word. Then, beta activity, that kind of speaks to rumination. How much, it's not anxiety, it's more rumination, how much awareness you have of your environment and your surroundings. Okay, that's important because I'm going to come back to that later. So that's beta, that's frequency activity. The second kind of activity is called event-related potentials, or the attentional processing. So what happens is you can show somebody or participant, you can show them something on a computer screen, you can show them an actual object, or you can show them something on a computer screen. And then you can measure their brain activity. This red kind of like waveform here represents 800 milliseconds in time. It's less than a second. But you can see that different components arise in that waveform. For example, I've highlighted here in red the P200. It's called the P200 because it's a positive deflection at 200 milliseconds post-Q exposure. This is happening 200 milliseconds after I've shown something to somebody. That waveform is associated with subliminal attentional processing, pre-conscious attentional processing. Before your brain knows what it is, before there's been enough time elapsing for your brain to know what it is in front of you, it's how much attentional processing is happening. So it's more kind of the pre-conscious, pre-attentional, the kind of innate response. Then, with the P300, once again, positive deflection at 300 milliseconds post-Q exposure, this is when your brain has clicked. Okay, I've gone through my memory circuits, and I know this is a donut. So now your brain knows what it is, right? So that's more of a conscious thing, and it's related to motivated behavior, because once your brain knows what it is, it can motivate itself to either do something or not do something, right? So it depends which component you're looking at in this spectrum. So we did 2 EEG studies on South African women. In the first study, at the top there, we looked at normal weight versus overweight versus obese women, right? In the second study at the bottom, we looked at successful dieters versus unsuccessful dieters. And we measured how their brain activity responds to pictures of palatable food. We chose palatable food, so food that looks like it tastes good, food that has high caloric value, and food that is, very importantly, processed food. We only showed them pictures of processed food most of the time. So I'm going to flip this graph around at the bottom here, because it makes more sense if you look at it upside down, because we have these weird conventions in neuroscience to flip things around, and then nobody really knows why we do it, but we do it. If you look at this graph upside down, it makes sense. So these are data which we extracted from the parietal cortex, from the right parietal cortex. So it's this part of your brain here, the right parietal cortex. And this was in response to visual food cue exposure in our normal weight and our overweight and obese women, right? Okay, the red line over here, that's our overweight group. The green line is our obese group, and the blue line is our normal weight group. You can see here at the P200 mark, the overweight group showed a significantly higher level of brain activity than did the obese group and did the normal weight group. So pre-consciously, our overweight woman showed a difference in brain activity there. Then you can see our obese group, they really went into hyperdrive during conscious attentional processing. Once their brains knew what it was, their brain activity was the highest in comparison to their 2 counterpart groups, right? So there were measurable differences in brain activity over the right parietal cortex in response to food cue exposure in these groups. Still from study 1, we found that in the DLPFC, the dorsolateral prefrontal cortex, parts of your brain up here in the front, those parts of your brain are associated with higher mental functions. So motivation, attention, inhibition. Inhibition is a very important one in here. We found that the overweight and the obese women showed much lower activity there. They were less able to inhibit behaviors, right? It's a funny thing. The same thing happens in anorexics, but it's the other way around. They have very, very good prefrontal cortexes. They have they're so well overdeveloped and so primed that they can control anything with their brains. They can control any behavior with their brains. Whatever it is, they can control it. The opposite happens in obesity. Those parts of the brain are a little bit less primed. That was the second finding. Then we also found in study 1 that a part of the brain called the sensory motor cortex was a bit more activated in our overweight and obese women. So and interestingly, and this has been documented in other studies, that this is the part of the brain that's associated with hand-to-mouth movements. So those neural circuits that are associated with eating movements and eating behaviors are even more primed in overweight and obese women. Then this was from study 2. we looked at the successful dieters versus the unsuccessful dieters. And we found that over here, the blue is the unsuccessful dieter, and the red is the successful dieter. You can see here that the unsuccessful dieter showed a much higher level of delta activity. Remember, we said that it was associated with addictive behavior and dopaminergic response. So they show much more addictive-like responses. Then, with the beta activity, the successful weight loss maintainers, the red group here, they showed higher levels of beta activity. And remember, beta activity was awareness of the environment. So they're aware of what's in the environment, but they are less likely to engage in addictive behaviors, depending on what's in that environment. Okay. So that was clue number 5. There's a link between sugary processed foods and addictive eating behavior. Okay. So let's just quickly review what we've looked at so far. Our first clue was that decreased sugar associates with successful weight loss maintenance. So when we looked at those 2 donut-shaped graphs with the red, blue, and green, we found that decreased sugar happened in our successful weight loss maintainers. The second clue was that our successful weight loss maintainers, they have less flexibility. They're less able to switch over between fat metabolism and carbohydrate metabolism. The third one was that we found a link between obesity and the brain, right? Because there's an over-report and an under-report of physical activity and calories. And then we also found that low calories and sugar equaled weight regain when we looked at the flux study, those fluxers. And we also found that sugary and processed foods activated or deactivated addiction circuitry in the brain when we looked at our EEG data. So what's the common thread? Sugar, right? Okay. So let's just delve back into history, and we touched on this very briefly yesterday. So on September the 23rd, 1955, something happened that drastically changed the way that we see sugar and foods. And that was Dwight Eisenhower, who suffered from a fatal heart attack. And so this was the first time that we started seeing things like cardiovascular disease emerging in the public domain, and people really talking about this widely. So 2 main theories really came up from this event, and that was Ansel Keys on the left and John Yudkin on the right. Ansel Keys was an American scientist, whereas John Yudkin was a British physician. Ansel Keys, like we said yesterday, he was the one that said that fat was the problem. That was the biggest problem that we have. That's why obesity and cardiac disease exists. Whereas John Yudkin said that sugar was to blame. So in the end, Keys won over Yudkin, and fat became vilified. And we all started going on low-fat, low-calorie diets, and sugar was just completely okay and exonerated. And this is when the low-fat movement began. And in the 1970s, the Sugar Association actually they hired different PR agents at different companies to cover up what was really going on. This was when the US government reviewed the safety of sugar for the first time, and there was little empirical evidence. So the amount of pliability that companies and big financial inputs had on the messages we received about food and macronutrients really became a problem. And this was also mirrored by normal lay newspaper articles, like there was a headline of scientists dispel sugar fears. There was nothing done research-wise on this at the time. So, I mean, I know we all know that large corporations really do influence public messages and what we receive in the media. And if we think about the Heart Association, the Cancer Association, those kinds of endorsements are around us all the time. When I went to the US for the first time, guess who funded my travel grant to go and present my obesity research, that EEG research? Guess who funded my travel grant? Coca-Cola. Coca-Cola paid for my plane ride to the US when I was a first researcher. And I mean, when you're 23, if you're going to get money, you're going to get money. You know, like you're not going to not go. So it's interesting how there are these interesting little collaborations between obesity researchers and big companies. And really, those kinds of studies that review sugar and fat and come up with no association between sugar and metabolic disease, who really funds those? Just like we saw with my little plane ride to the US. So, but the problem was that when you start extracting fat from food, you really do make it bland and you make it less palatable. And the only solution then is to inject more sugar. And if you go to any grocery store, I don't care if you shop at Woolies or if you shop at Pick n Pay, if you go to any grocery store and you remove all of the products from those shelves, what will be left? What percentage of products would be left if you removed all of the sugary products from that store? What do you think? Well, percentage-wise, how much? 20%? 80% of our products in our grocery stores are pumped full of sugar, and most of the time we don't even know it. So, not surprisingly, the average South African consumes 40 teaspoons of sugar per day. And you might be thinking, okay, well, what are we doing? Are we eating junk food and candy all day? Is that how we get to 40 teaspoons per day? No, that's not how we get to 40 teaspoons. We get to 40 teaspoons by eating products that are labeled as healthy, products that manipulate us into thinking that, hey, this is cool, like there's no fat in here, so this must be good. So those healthy cereals and those low-fat mayos that you add to everything, it might be time to revisit the idea. But speaking about sugar, let's just revisit on a physiological and a biological level the sugar family. So glucose you derive from breads and veggies and grains, and this really is our body's main energy source, right? We were all taught this from biology days in high school. And so if you had no glucose, there'd be no you, because this is how your brain and your cells and your organs really fuel themselves. And lactose, similar, sugar too, but this comes from a different source. It's more of a dairy source. And interestingly enough, people that have lactose intolerance, it's not that lactose is bad. It's just that they lack an enzyme to break down the lactose. It's not that lactose itself is bad. Okay. Then with sucrose, this is table sugar. Sucrose, this component of the family is what we have in our tables, and this is composed of 50% glucose and 50% fructose. And fructose I've highlighted because that is really where the problem comes in. Fructose, if we look at evolution and history, has been very, very rare in nature. There are very, very, very small amounts in fruits, veggies, and honey. But this is how we extract all of these sugars and we pump them into our foods, and that's how we sweeten things. And the funny thing is that our body has no way of sensing how much fructose we eat. Our physiological systems don't really have a checking system for how much fructose we have. With water and with most foods, homeostatically you can control, I'm done now, I'm full. But with fructose, you don't really have those subtle physiological mechanisms which regulate that. The problem with fructose is that because we can't metabolize it so well, it gets converted straight into fat, called triglycerides. And triglycerides freely float within our bodies, in our arteries and our veins. And they just float around until they clog up something. And interestingly, after 2 months of added sugar, your triglyceride levels can go from 0.8 to 1.5. 0.8 is quite healthy. 1.5 breaks through the unhealthy level. So just after 2 months of adding sugar to your diet, you can go from being really good to being really bad. Another thing I want to talk about is visceral fat. Visceral fat is the fat that's inside of your abdomen. When you see somebody that has a lot of subcutaneous fat, the fat that maybe makes your thighs not look so great or gives you those little flabby flaps under your arms, those aren't the things we're worried about. We're worried about the fat that's stored between your organs, the ones that cramp your organs up and give them no space. And in medicine, we call this a toffee. We call them thin on the outside and fat on the inside. Because you see a lot of people that walk around, they look skinny and they look good, but they might be the most at risk for getting ill. I think if you think about somebody that's a chronic alcoholic or somebody that is a drug addict, those kind of phenotypes pop up in those streams as well. But anyway, the toffee phenotype predisposes us to metabolic disease or metabolic syndrome, and this is a cluster of problems with our biology, really. It's an increase in visceral obesity, so an increase in visceral fat around our organs, an increased likelihood of type 2 diabetes, the free-flowing fat in your blood, that's higher. You have lower HDL cholesterol. HDL cholesterol is the good cholesterol. That's the cholesterol that sucks up the triglyceride in your fat and takes it to your liver to be processed. That becomes lower as well in this toffee phenotype. Also, hypertension or high blood pressure kicks in a lot sooner. Another thing here is that because we eat so much sugar, our finely tuned tasting systems, the way that we perceive food on a basic physiological level has become so complicated. If you think about salt as well, there was a big fad about salt a few years ago. If you stop adding salt to your food, within a few weeks, all of the food that you eat will become a lot more tasty. You'll start tasting the natural salts and the natural minerals in food, right? The same thing happens with sugar. The thing is, 80% of our products have sugar in it, so we can't really gauge how much sugar we're really eating. So we really have a sensory overload all the time. So it's over and above, those metabolic systems that get activated. It's actually on a fundamental sensory level we're impaired, and that's scary. And the reason I put this picture up here is because nature has given us this beautiful little package, right? An apple, an orange, it's perfect. It's got a bit of the bad, it's got a bit of the fructose to make it taste a little bit good, and it's got all the fiber, right? But today we all buy these juices, we just extract all the juice, and we throw away all of the good stuff. You just have all the sugar, and you throw away all the fiber. And that makes no sense to me. And that if you have to get this amount of apple juice, with basically most of it being fructose, you produce about 10 apples, and then you throw all the fiber away, the soluble and the insoluble fiber. And then I want to speak about the liver as well. We get an enzyme in the liver called ALT, or alanine transaminase. And this is a marker of hepatocyte dysfunction, or hepatocyte breakdown. Hepatocytes are your liver cells, right? If you have higher levels of ALT in your blood, that means there's something going on with your liver cells. They're breaking down, they're degenerating. And this ALT becomes elevated in people with obesity, mostly because obesity predisposes us to hepatic steatosis, which is it's kind of like a fatty liver. And you can actually see this on microscopy. It's amazing. You can see big globules of fat on the liver. They look like big little drops of water that have replaced your liver tissue. But in a month of eating more sugar than you should, your ALT levels can drop from 20 marks below the safety line to 20 marks above the safety line. And also, this pushes you from being in the 20% of the worst 20% in the worst part of the population to being in the 10% of the best population. So you can jump from one spectrum of where you sit on the continuum of unhealthy to healthy to being right on the worst, just by adding sugar to your diet. And also, with this ALT and the hepatocyte dysfunction, we get something called liver cirrhosis. And once again, in medicine, we call this a nutmeg liver, because your liver really gets this nutmeg. If you've ever ground down nutmeg, it's got like that kind of like rough texture. Your liver literally looks like that. It's amazing. In pathology, we name most things after food because it really is the best reference. And liver cirrhosis, a nutmeg liver, predisposes you to hepatocellular carcinoma. And that's liver cancer. And liver cancer is one of the most aggressive cancers you can get. So I want to speak about the bliss point as well. I don't know how many of you know this, but obviously you know that most of our products don't originate from within the country, they're imported. Or at least they originate from bigger corporations that have branches all over the country that are regulated from a central point somewhere else. Most foods are engineered to have a bliss point. A bliss point is that level of sugar which a food must have to make you perfectly happy, because too little will not make you satisfied enough, and too much also it's kind of an inverted bell curve. So there's a perfect amount of sugar for every single food that you can eat. Too much can be too sweet and horrible, and too little cannot activate those neural circuits. And every single food has a different bliss point, and most foods have been engineered to be perfectly within their bliss points. So if that doesn't speak to how much we are being manipulated by foods and what we eat, then I don't know what does, because what we eat has been modified and changed to be perfectly palatable and to perfectly activate the parts in our brain which enjoy food. And that's very scary. And then I also want to touch on how sugar, when you withdraw from sugar and sugary substrates, that this kicks in all of those same kinds of behaviors that somebody would experience after going off actual drug addiction. You get headaches, you get moodiness, you can't sleep, you get intense cravings, and these things have been documented to last for about 2 to 4 weeks. But luckily, if you do stop soon enough, most of those natural physiological, behavioral, and perceptual things do restore to normal. However, I just want to, because I have a history of using sweetener, because I thought, it's fine. But after reading quite a few studies, with sugar, it's not so much that it's bad, with the artificial sweetener, it's not so much that it's bad for your gut or your gut microflora, it's more that it reinforces the message in your brain that something must be sweet for it to be good. Something must be sweet for it to taste good, and something must be sweet for it to be enjoyable. So that's the problem with artificial sweetener. And you'll find that if you do use artificial sweetener, you'll start using more and more and more. Okay. And then to end off with, I've got 5 minutes left, so I think I've done okay. There's enough time for questions even. So I want to speak about the Aboriginal Australian. In 1973, these people would consume the equivalent of 2 teaspoons of sugar over a year, because most of their food would come from natural sources. Then a foreign grass was introduced to the landscape, and that kind of destroyed all of the natural fauna and the flora. It was just deteriorating. Today, these people have the highest level in the world of kidney failure, asthma, heart disease, and diabetes. And they're all linked to obesity. All of these people that have these conditions are obese and overweight. And that if that doesn't speak to how those minor changes in what we eat and what is introduced to our culture and to our society changes our bodies in the end, I don't know what does. And the reason that I chose this was because those stores sold only processed foods. Those stores, and to this day, they only sell kind of pre-packaged foods that have long shelf lives and loads of preservatives pumped into them. Okay. So ask yourself, before I see you tomorrow, just ask yourself, if we didn't have so much sugar in the world, and if we didn't consume so much sugar, would we be obese and would we be sick? Thank you very much, everybody. Okay, I'm dying for questions. Yes.
Would you like to say something about the role of gut hormones influencing our minds?
Well, I've only looked at the gut microflora, so the gut microbiome. So I have a collaborator, her name is Deshni Keswal, and she looks at how obesity relates. So the question was, how have I looked at gut hormones and how that is implicated in obesity? And yes, well that's good. Good, then I've got the right answer. So with Deshni, she looks at how the gut microbiome, which is really a big composition of all the flora in your gut, how that implicates brain activity. We're in the process now. We're doing an EEG study where we're getting fecal samples at the beginning and at every time point after get a 6-month sample and a year-long sample to see if those changes in gut microflora before and after bariatric surgery or weight loss surgery versus people that go on a natural weight loss journey doing just dietary intervention, if there are changes in gut microflora and if those changes in gut microflora relate to changes in EEG. So I will answer your question when we're done with the study. Any other questions? If you're too shy, you can always come to me afterwards, but more questions? Yes.
Wondering about the initiative with Vitality Health and encouraging people to change their lifestyle. Has there been anything done around that?
Not as far as I know. I'm sure most of you all followed the news last year with Tim and the controversy, but I don't think until there is like I was speaking about prospective data, longitudinal data, unless we have more of that, I don't think on a kind of policy level they can make any changes. I know that some things in some countries are changing, like tax like sugary foods being taxed, for example. But on a health insurance level, I'm not aware of any changes happening because of sugar versus fat and macronutrients. And that's what I was saying this morning when I was studying for my med school exams, which are on Friday. I still can't believe that we prescribe 50% carbohydrates to especially ill people. Yes. That's going to answer, she's yes.
That was a lot of quite detailed and interesting information. Is it possible to have it online so that one can reread it and revisit it?
Yes. So the lady's asking if we can have everything online. Beforehand, I was asked if we can record this. I don't know the policies around distributing the recorded material, but if not, you can visit me afterwards and get my email address and I can send you my slides, for example, if that'll help. Okay. Questions?
Around fructose, so you're saying that fruit is okay, but in its wholesome form?
Yes, absolutely. The level of fructose in natural fruit and veg is minimal.
Yeah.
I think the only time that dietitians get a bit worried about fruit is because it does have a bit more energy than does vegetables, for example. But fructose is not a problem at all whatsoever. Yeah. Any other questions?
Just percentages that you recommend around protein.
I will be shot dead in my tracks if I answer that question by some dietitian or by some health professionals council person. So I can't prescribe. Yeah, I wish I could, but I can't. Any other questions, anybody?
I suppose we could ask what you follow.
Well, that's why the flux study was so fantastic to me, because I go running every single day for about 45 minutes to an hour. Doesn't matter, like today, wasn't it like 35 degrees today or something ridiculous? I was on the mountain at like 3 p.m. today running. And I eat at least six or seven times a day. I do try and steer, my main rule is just stay away from anything that's processed. Anything that's, I'll speak about it tomorrow, but it's called the farm to table rule. What way better to understand obesity and overweight than to look at the journeys and the differences between the successful dieter and the unsuccessful dieter. That's a really nice juxtaposition to kind of kick off with, and just to kind of explore the differences between people that actually do end up reaching their goal weight and maintaining a healthy body weight versus people that always struggle with unhealthy levels of adiposity throughout their lifespans. So sadly, only about 20% of us who start diets reach our goal weight and manage to keep that weight off. And for interest's sake, this was part of my PhD, it was part of my literature review, and for interest's sake, the top 8 behavioral or physiological attributes of the people that successfully maintain weight are these 8 here. They look a bit blasé and a bit bland now, but these are all from empirically controlled for studies, from really good studies which have been published in The Lancet and several other journals which really have great impact factors and are very reputable. But the first thing here is that successful weight loss maintainers tend to consume a low-energy, low-fat diet. Don't let the low fat confuse you, though. That we are referring here to trans fats and hydrogenated fats. So these are unhealthy fats, not healthy fats. Then the daily consumption of breakfast. So your grandmother and your mother were onto something when they said breakfast is the most important meal of the day. Obviously, and not surprisingly, these populations tend to engage in at least moderate to high levels of physical activity every single day of the week. They also show monitoring behaviors, such as frequently weighing themselves or measuring themselves. Also, elevations in eating restraint. When I say eating restraint, I'm referring to how much of my cognitive capacity, how much of my mental capacity I can use to control my eating behavior. How much of what I think and what I can control, top down, can I stop and inhibit? So these people are really good at inhibiting behavior to that degree. So before I begin, I would just like to extend my most heartfelt thanks to Brian for covering our first lecture. I've always had immense trouble contextualizing and conceptualizing the humanities and the social sciences, and whenever Brian speaks about it, it always seems so easy, but when I try and read up on it, I do get a bit carried away and confused by the whole topic. But before we begin, it's Ryan, right? He's our mic guy. He has to leave at 8:30, so if we do run over time, which we very much are likely to do, I'm going to switch the mic off, he's going to pack it away, and we'll continue the discussion without the microphone. I'll start screaming at that point, and then hopefully I'll be able to project my voice. But today we're going to step outside of the social sciences, away from politics, away from philosophy, and away from the humanities, and get our hands dirty with something that I find a bit more comfortable, and that's biology and physiology and how our brains really are implicated in obesity. As Brian mentioned, I had a year or two where I stepped away from doing studies. After my PhD, I was a bit fed up, so it took a year or two just to kind of, do some work, and now I'm back at university studying medicine and surgery. So it's very nice to be in front of the class for a change again, as opposed to sitting in a class of 260 third-year medical students. So it's nice to be in control again. But today, I want to just revisit the statistic, which I think that Brian did mention briefly yesterday, and that was the frightening fact that in 2014, the World Health Organization empirically supported the fact that 39% of our adults aged 18 years and older, and 39% are overweight, and 13% are obese globally. Also, they recover very quickly from small weight relapses. If they pick up 2 kilograms or 3 kilograms, they lose it within a few weeks. It doesn't stick around for very long. They also limit screen time, once again not surprising in our day and age, limited TV, limited PC usage, and also, this was surprising to find in a study, but a really good and effective weight management during the holiday periods. And coming through Christmas and New Year's, I think we can all understand why that is high on the list. I mean, this happens once every 12 months, and that definitely accumulates after years and years of over-consuming over the holiday periods. So these data, for interest's sake, were sourced from the National Weight Control Registry. And the National Weight Control Registry is the only registry in the world that has over 5,000 people in it that have managed to keep their weight off after being overweight or obese. And this data set is based in the US. And it was founded by someone called Rena Wing, who is based at Brown Medical School. And I was lucky enough to meet her a few years ago when I went to my first US conference. So a really good way to explore what successful people do to keep weight off. And this database is continuously updated and continuously trawled for data, and immensely good studies emerge from this data set every single year. So what about the rest of us? The 80% of us that are never able to reach that goal weight and keep it off. Surprisingly, most of us do reach our goal weights, but it's the relapse that kicks in really shortly. So within 3 to 6 months, you'll find that most people that have lost weight have regained it all. But what is it that pushes us back to square one? Why do we relapse? And that was really my fascination, and that's what really made me passionate about doing my PhD. What causes weight relapse? And for interest's sake, the reason why I went into obesity research was because I was obese as a child and as an adolescent, and I really struggled with it. So it really was something that hit home and something I wanted to risk.
Thank you, Ryan. Hello, everybody, and welcome back to the second installment of Obesity in South Africa. Thank you for coming back today. You're in for a real treat. It is my absolute honor today to introduce you to my dear friend, David John Hume, Dr. David John Hume. And I'm going to give you a little brief introduction to him. So, born in Uitenhage in the Eastern Cape in 1988, David spent many of his formative years growing up on the family farm in the Klein Karoo. After matriculating from Union High School in Graaff-Reinet in 2006, he went to Stellenbosch University to do his undergrad, graduating cum laude, majoring in sports science, psychology, and English literature. He then made the best decision of his life to come to UCT, where he did his honors and his doctorate at the Department of Exercise Science and Sports Medicine. There he graduated with a PhD in sports science, and the title is Mind the Gap, Brain Behavior Barriers to Successful Weight Loss Maintenance. He graduated in 2015, where he was also appointed assistant lecturer in the department. Since then, he's been an ad hoc postdoctoral research fellow at UCT's Department of Psychiatry, and he is now a third-year MBCHB student in the Faculty of Health Science. David has been granted numerous international awards and research grants, including in 2015 being honorarily invited to join the Bright Young Minds, which is a very prestigious fellowship organization which selects 100 of South Africa's emerging leaders under the age of 32 to foster. So everyone, please welcome my dear friend, Dr. David John Hume.
Wow, I'm already blushing, and that was quite unexpected. I didn't know Brian was keeping tabs on my life to that globally. And that means that most of the population that lives on our beautiful planet live in countries or on continents where more people die from overnutrition and obesity than they do of underweight, wasting, and malnutrition. But then where does South Africa fit into this context on a biological level? We did speak about South Africa's problematic political history yesterday, but where do we fit in with statistics? So about 25.3% of our male population, these are our adult males, are overweight, and 13.5% are obese. And as you can see here, a staggering 27.3% of our females are overweight and 42% are obese. So I'm picking up a lot of interference with the mic, but hopefully that'll resolve itself. Is it really bad, or am I just hearing things?
So when you move it by hand.
I'm trying not to move too much. Okay. Just fix that before I continue, because there's nothing worse than a whole lecture where you can't hear somebody. Is that better? Can you guys hear me? Back? Good. Okay, so a staggering 42% of our female population in South Africa are obese. And people always ask me, why do you study females? You'll see whenever you read any of my research or look at any of my data, it's always on female populations. And that's firstly because obesity does burden our female population to a much greater degree, and secondly because when you look at one sex, you really do control for intersex differences. So, and females biologically are a little bit more complex than males because females' endocrine systems are a little bit more convoluted and complicated. So it's a bit easier to control downwards, to take away variables and to add extra variables, if that makes sense. Okay, so I thought when I put together this talk,